These are the tips to sketch the graph of exponent and logarithmic by using tick and draw. I classify into these three conditions. The first one, to identify the quadrant. Here, the quadrant 1 is identified by look at the value of x and the value of y of the function. So, for example, for the positive x and positive y, the graph must be starting from the first quadrant. For negative x and positive y, the graph must be started at the second quadrant. Same goes to the third quadrant, negative x for negative y, and the fourth quadrant is when x is positive and y is negative. Okay, next we need to identify whether the x-intercept or y-intercept exists for the certain function. And the last part, we need to consider whether the horizontal or vertical asymptote exists. We go detail into exponential function here. Given fx equal to a to the power of x, where x is element of real number, a must be greater than 0 but not equal to 1. The basic shape for this function, by looking the value of a greater than 0, here are the basic shape we can get from this value of a. For a less than 0, here are the graph, the basic shape we get from a less than 0. For example 18, we need to sketch the graph of fx and determine its domain and range. Before we start, I need to share with you the basic shape for exponential function can be remembered by looking the alphabet E. Here we know that the graph for exponential function always cut the y-axis and the asymptote is always horizontal. So first step, we need to identify the quadrant first. By looking the coefficient in front of exponential function, here we get positive value of y. And by looking the coefficient of x, here we get the positive value of x. So our conclusion is the graph must be start at the first quadrant, since the value of x and the value of y is a positive. Second step, we need to identify the intercept. By looking the basic shape of the exponential function, here the intercept involved in this function is y-intercept. So we need to substitute x equal to 0 and get y equal to 1 as intercept at y. The last step is to identify the horizontal asymptote. Horizontal asymptote can be determined by looking the constant value beside the exponential function. Since the given fx equal to 3 to the power of x, so here we can conclude that the horizontal asymptote exists at y equal to 0. So by looking this graph, this is our horizontal asymptote. This is the starting point of the first quadrant. This is a y-intercept. So the graph for this exponential function can be drawn like this. So from this, we can read the domain of fx is always negative infinity to infinity, and the range of f must be read from the horizontal asymptote y equal to 0 up to infinity. Now, we need to sketch the graph for fx equal to 5 minus 2e to the power of negative x by taking fx equal to 5 minus 2e to the power of negative x. So we start with to determine the quadrant for this function started. So by looking the coefficient of x, we can take the negative value of x, and then by looking the coefficient for exponential function, here are negative 2, and then we can take the value of y is negative. Here are the negative x and negative y, so it means that the graph start at the third quadrant. Okay, second step, we need to identify the y-intercept for this graph. So by taking x equal to 0, so we need to calculate y equal to 5 minus 2e to the power of 0. After simplify, so we get y equal to 3 as the y-intercept. So starting with the third quadrant, and then intercept at x equal to 0, y equal to 3. And the last step is to determine the horizontal asymptote. Horizontal asymptote for this exponential function, we just taking the constant value of this function fx, 5 minus 2e to the power of negative x, by taking the constant value beside the exponential function given here, y equal to 5 as the horizontal asymptote. So here are the line y equal to 5. So the graph for our function here can be drawn starting from the third quadrant and passes through the intercept and approach to our horizontal asymptote y equal to 5. So by looking this graph, we can determine the domain of fx is always a real number, negative infinity to infinity, and the range of f is determined by looking the graph from negative infinity and stop at the horizontal asymptote y equal to 5.